Welcome to the Incident and Near-Miss Reporting e-course of the Helmepper's VIRP. VIRP, which stands for Voluntary Incident Reporting Platform, is a platform that allows marine professionals to share safety-related information from incident reports. It is a valuable tool for shipping companies and small craft users to communicate near misses, lessons learned, and other safety issues in an anonymous and voluntary way. The scope of this program is to contribute to the prevention of future accidents, loss of life, and injuries at sea. VIRP was developed as part of the project titled Enhancing the Understanding of New and Enduring Challenges on Maritime Safety Culture in the East Mediterranean. The project is coordinated by Helmepper and implemented in cooperation with partners Lloyd's Register, CIMEPA, and Dyna Marine with the kind support of Lloyd's Register Foundation. This course is an introduction to the design of an incident reporting system in the maritime industry, and it also presents the design features of VIRP. The course is divided into 3 parts. The first section deals with the design of a modern incident reporting system. The scope, the principles, and the design requirements are described. Moreover, the difficulties and the expected obstacles that prevent an effective implementation are also discussed. The second section presents the incident report of VIRP as a case study and as an application example of the principles discussed in the previous part. The incident report form is considered a determinant factor in the effectiveness of the entire system. The final part of the course is dedicated to statistical analysis. Statistics has great potential in revealing hidden trends and in guiding forecasts. Nevertheless, the statistics should be used with considerable caution. The characteristics of the sample and several assumptions on which the statistical analysis is based are often overlooked. Statistical results, without considering the framework of the analysis, could be misleading, jeopardizing the credibility of the entire methodology. For the sake of this educational session, selected automatic statistical results derived from the incident reports during the pilot phase of VIRP will be presented and discussed. The entire course has an approximate duration of 40 minutes. Since this course is not a general introduction to safety, it requires some basic knowledge about safety and environmental awareness, as well as a basic overview of modern management systems. Although the terms incident and near miss will be defined, it is assumed that the audience has already been introduced to relevant terminologies such as HSE, incident investigation, plan, do, check, act concept, risk-based approach, and corrective versus preventive actions. The course is addressed to officers related to the so-called HSC, Health, Safety and Environmental sector of the shipping industry. The following professionals will find this course helpful: staff working in the HSE-related departments of shipping companies, safety and environmental officers, mariners of management level ranks. The objectives of the course are to assist attendees to understand the importance of the potential consequences of an incident, realize the importance of identifying and reporting near misses, learn what the fundamental principles of an incident reporting system are, effectively utilize statistical analysis of incidents, be able to submit reports in VIRP, and understand the benefits of being subscribed to VIRP. This course is prepared by Stelios Perisakis on behalf of Dyna Marine Academy. Dyna Marine Academy is an ABS certified and ISO 9001 accredited maritime training center with almost 1 decade of experience. Currently, it offers more than 50 different IMO courses and is continuously organizing webinars and seminars customized to clients. It also supports the unique STS service of Dyna Marine with original STS courses and other educational material. Stelios Perisakis' background is in naval architecture and marine engineering. He has both academic experience and marine consultancy experience. He is currently also an active surveyor and lead auditor. As a consultant, Stelios Perisakis has long experience in ship-to-ship transfer operations, risk management, and incident investigations. Definitions and principles. An incident is an event or occurrence, usually unforeseen, that disrupts or adversely affects normal operations or puts people, property, or the environment at risk. In occupational health, safety, and environmental management contexts, an incident can refer to an unintentional and unexpected event that does or has the potential to cause harm or damage to people, property, or the environment. Intentional events refer to security incidents that are out of the scope of this presentation. The term incident includes accidents and near misses. A near miss, a near hit, or a close call is an incident with the potential for an adverse outcome that fortunately does not happen. In a near miss, the series of events of an incident is initiated, and the situation starts to evolve when it is interrupted before significant damages occur. The most important characteristic of a near miss is its potential. The reason that any severe consequences have been prevented could be either luck or an effective control measure. However, this is not of primary concern. The initial objective is to identify and correct hazards before they result in harm. An incident may or may not be considered a near miss, depending on the context, among other factors. For example, a delay that does not cause loss or significant inconvenience for a ship manager may be classified as a near miss. However, from the charterer's point of view, who probably suffers additional costs and delays, the same event is classified as a typical incident. Whenever you feel uncomfortable marking an event as a near miss, take a step back and study the context of your analysis. In general, the results of an incident are not only direct losses such as personal injury, property damage, or pollution. The impact of an incident may also spread to additional indirect consequences that are not immediately apparent or measurable, and they can have significant long-term effects on the organization and the wider community. Thus, qualities such as an organization's reputation, trust, premiums, and risk of investment are affected by an incident and may result in significant business disruption to a company. Similarly, several systemic disorganizations in the overall logistics as an outcome of an incident may also threaten the sustainability of a business opportunity. For example, an incident that results in an oil spill may have direct consequences, such as damage to marine life and cleanup costs, but it may also have indirect consequences, such as lost income for local fishermen and negative impacts on the tourism industry. Similarly, a workplace incident that results in a severe injury to an employee may have direct consequences, such as medical expenses and lost productivity. Still, it may also have indirect consequences, such as a negative impact on the company's reputation, lost contracts, and higher premiums. Not all health and safety incidents are serious in their effects, as is the case with near misses. However, the final effects are not the only metric of their severity. The potential impact of an incident is equally important. The concept is that high potential incidents, incidents with a high potential in resulting severe consequences, and near misses are severe incidents waiting to happen. By analyzing the underlying causes and contributing factors, Organizations can identify potential hazards and risks and take proactive measures to prevent incidents and injuries in the future. They are a window to the future that gives us the comfort of time to build appropriate controls to prevent incidents. This is why the prudent response to incidents tends to be unified for both near misses, minor incidents, and severe incidents. All have to be recorded and analyzed, their potential has to be estimated, and suitable safety measures have to be established. Identifying near misses can be challenging because they are events that did not result in any injury or damage and therefore may not be immediately apparent or obvious. Incident reporting systems, safety inspections, and hazard assessments will assist companies in identifying near misses. All these are important measures and signs of a sound safety culture of a company. However, by far the most effective way of near misses identification is to involve employees. Organizations should actively seek near misses and encourage employees to identify and report them. The key point is involvement and awareness. While training is not always necessary to identify near misses, it can raise awareness and improve the ability of employees to identify potential hazards. It also assists in understanding the importance of doing so, strengthening further their involvement. Let us look at this picture more thoroughly and assume this is a day without any incidents. Can you identify 13 reasons that prove this day was only a lucky day? You have 1 minute. Making notes may help. Look where these people are and what they do. Are all safeguards in place? You still have 20 seconds. Did you find all 13 near misses? Look at the red circles and the white number on its right. 1. Wire is wrapped around her feet. 2. Spills on the ground are not cleaned up. 3. Standing in a restricted area. 4. Not wearing his hard hat. 5. Not wearing ear protection. 6. Guard is not protecting the saw blade. 7. Smoking next to oil cans. 8. Not wearing eye protection. 9. Smoking in a no-smoking area. 10. Boxes are covering the fire exit. 11. Carrying something too big and heavy. 12. Poster covers a health and safety sign. 13. Boxes are stacked too high. Fundamentals on Incident Reporting Systems. The main objective of HSE is to create a safe and healthy workplace for all, where hazards and risks are identified and managed to prevent incidents and injuries. In light of this objective, all procedures of the company's safety management system must be reviewed to identify possible hazards and integrate suitable risk control measures. The process may need several attempts at hazard identification and risk-preventing barrier implementation, while at the same time the scope and efficiency of the procedure should be maintained. This process undoubtedly leads to robust and low-risk procedures and is a significant step forward. Unfortunately, reality has proven that this is far from enough, as there are always threats that escape this approach waiting to initiate incidents. Further awareness and effort are required in a continuous and persistent way in order to identify hazardous situations soon enough to prevent possible or evolving incidents. There are two dominant methodologies that all modern management systems utilize to raise awareness of the remaining unidentified hazards. These are the continuous improvement concept and the risk-based approach. Continuous improvement is an ongoing process of identifying opportunities for improvement, making changes, and measuring the impact of those changes with the goal of continuously improving performance and outcomes. The structure of the continuous improving process is based on the typically cyclical plan, do, check, act methodology. In the health, safety, and environment context, continuous improvement involves a systematic approach to identifying and addressing hazards and risks, and continuously improving policies, procedures, and programs to prevent incidents and injuries and minimize environmental impacts. Incidents and near misses play a fundamental role in this concept. Through continuous improvement, each incident and identified near miss is concluded with lessons learned and recommended preventive measures. The continuous improvement concept also includes the last mile, which consists of monitoring the implementation of preventive measures. A risk-based approach is a systematic approach to managing risks in which decisions and actions are based on analyzing the likelihood and consequences of potential risks. This approach involves identifying, assessing, and prioritizing risks and implementing controls and mitigation measures to manage or eliminate those risks. The risk-based approach typically involves incident and near-miss investigation in order to identify potential hazards and risks associated with business operations and evaluate the likelihood and potential impact of each hazard. Since resources are limited in the real world, prioritization of risks assists in using available resources more efficiently. Experience has shown that there is no magic recipe to foresee all the imminent hazards. After a thorough initial analysis, all we can do is continuously study incidents, unveil unidentified hazards, and attempt to prevent them from reoccurrence. Incidents are the fuel of this process. Thus, incident recording is a vital task that powers the entire campaign towards safety. Furthermore, it is worth mentioning that while incidents have the additional cost of their consequences, near misses are assisting us for free. This is why near misses and, in general, high potential incidents are so important. The general term incident reporting describes an entire information system that includes both the procedures and the means for recording, managing, and recalling the information relating to the incidents. It is also closely associated with the procedure of identifying incidents and the procedure of continuous improvement based on the risk-based approach. Especially incident recording represents two different recording procedures that take place in different time periods. The first recording procedure takes place just after the incident. The scope of this procedure is to collect objective evidence and record all the details related to the event. This information will support corrective actions and, most importantly, the incident investigation. The utmost importance during this stage is to estimate the event's potential, which will also determine the resources that will be assigned for the investigation. The second recording procedure takes place after the incident investigation and includes the aftermath of the incident investigation, such as lessons learned and preventive actions. lessons learned and preventive actions are the analysis's main output, which also triggers the continuous improvement process. These recordings are also part of the company's experience that supports several KPIs, such as reoccurrence, and contributes to future incident investigations. It is worth mentioning that VIRP is a system that handles the second recording process and works complementarily to a company's incident recording system. Studies have shown that people are not keen to report failures. To do so, they need a healthy professional environment that supports and strongly encourages incident reporting. The following session will focus on the main obstacles that prevent employees from reporting incidents, and how to overcome these obstacles will be discussed. A blame culture is an organizational culture in which individuals are more likely to assign blame or fault to others for errors or failures, rather than take a collaborative and solution-oriented approach to address problems. In a blame culture, individuals are often hesitant to report incidents or near misses as they fear being blamed or punished for their involvement in the incident. This can lead to a lack of transparency and accountability, as well as a failure to identify and address the root causes of incidents. It can also create a culture of fear and mistrust in any system, including the incident reporting system, regardless of how transparent or effective it is developed. Stop work authority is the right or responsibility given to workers to stop work activities if they believe that there is an imminent danger or a potential risk to health and safety. This authority allows workers to intervene and stop work without fear of retaliation or negative consequences for speaking up. Stop work authority is an essential element of a strong safety culture, as it empowers workers to take an active role in identifying and mitigating hazards in the workplace. It promotes a proactive and collaborative approach to safety, in which workers are encouraged to speak up and share their concerns about unsafe work practices or conditions. To be effective, stop work authority must be clearly communicated, understood by all workers, and supported by a robust incident reporting and investigation process. It also requires a commitment from management to respond to and address worker concerns in a timely and effective manner, and to provide the necessary training and resources to ensure that workers are able to identify and respond to hazards appropriately. Fighting blame culture is not an easy task. It requires strong commitment and vigilance from the management. However, stop work authority is a significant step forward. An additional immediate measure that encourages reporting of incidents and overcomes the obstacle of a blame culture is anonymity. When individuals are assured that their reports will be kept confidential and that they will not face retribution for speaking up, they may be more likely to report incidents or near misses, which can help identify and address potential safety risks. Particularly for VIRP, which is an intercompany reporting platform, anonymity is a major feature that prevents companies from avoiding reporting due to competition and commercial issues. Anonymity is a fundamental principle in VIRP, which is achieved both by design and at the procedural level. The elimination of identification traces in logs and the development of the incident reporting form using predefined options in the majority of input fields instead of plain text is serving anonymity by design. As part of the standard manned validation process of the reports, the anonymity check strengthens further anonymity and trust. Poor personnel involvement has a negative impact on incident reporting and near-miss identification. Workers also feel disconnected from the safety process and are less likely to be proactive in identifying potential hazards. Experience has shown that poorly designed incident reporting forms that request meaningless information or details and do not assist in the accurate incident description disconnect employees from the safety process of incident reporting. Another reason employees lose their interest in incident reporting is the lack of or inappropriate feedback from the system. People need to experience, rather than be informed, that their contribution has value. They need to feel the impact on their job. They need access to the system and to see improvements in their workplaces. VIRP has a well-defined reporting form that is easy to understand and complete while giving access to the entire database of all previous reports. Automatical statistics provide additional feedback, and the analysis process as a whole is transparent. Another quite common obstacle is the complexity of reporting. A form should be and look simple. It should be comprehensive from the outset. The user should never have a dilemma regarding which option to choose or temporarily leave the page seeking further information to understand the question or the available options. Multiple options or categories should be clear and mutually exclusive. The case that a user cannot find the correct category means the form is not designed, by mistake or by decision, to register this specific case. Every piece of information should be registered only once. Extreme caution is required during the design of the form to avoid duplication of the data. Sooner or later, data duplication will obscure both user convenience and data quality. Data that has no value and will not be included in the analysis should not be required in the first place. Useless data are only a burden, loss of time, and add complexity. User experience is the overall experience that a person has when interacting with a system and is a determining factor in the success of any system. The incident reporting form should be designed with user experience in mind. For example, the way the questions are set is significant. The desired information should be as objective as possible. Thus, questions should clearly request facts rather than personal opinions. Moreover, questions should be precise in every possible way. All users should understand exactly the same to answer as close as possible to the objective facts, which is fundamental for the credibility of the later statistical results. In a multiple-choice question, the option "Other" should never be used. This kind of option mitigates the effectiveness of statistical results and eventually will destroy the system's consistency. The only case such an option could be useful is when the form's designer is unaware of the complete set of available options and seeks this knowledge from the questionnaires. If this is the case, then this option should always be accompanied by a text field in which the user will write down the missing information. Another critical factor for user experience is the required time to complete a task. Since the user's interest could be turned into frustration very quickly, measures should be taken to minimize the time necessary to complete each task. Finally, when designing an incident reporting system, the administrative burden should always be considered. Obviously, if the required resources do not fit the organization's available resources, the entire undertaking has no chance in succeeding. This section refers to the VIRP incident reporting form. All issues discussed in the previous section are applied in this example. What VIRP is? VIRP is a platform that handles incident reports. It is based on a voluntary and anonymous concept and allows the maritime community to share knowledge and reveal trends related to safety. Since the management and operation of the international merchant fleet have structural differences from those of small crafts and yachts, VIRP is divided into two independent sub-platforms one for each sector. Both sub-platforms share similar philosophies. However, features are fine-tuned to the requirements of the targeted fleet. The incident report form is a fundamental part of every incident reporting system. Each company has developed a form that fits its needs and especially its procedures. Such companies may have better, more efficient forms than others. However, a unique form that works for all companies should never exist. And this is fine as long as the framework is only one company. The situation changes if the aim is to bring many companies together. A unique intercompany template that fits all companies is simply impossible. For this reason, the VIRP project decided to design a new form that fits the specific VIRP procedures. This form is very simple and comprehensive and should be completed with the available information on every company's form. VIRP also has the feature to upload media related to the incident. This media can be uploaded by clicking in the particular area just under the logos and the form's title. The VIRP form begins with the date of the incident. Only the month and the year are completed to avoid traceability. The following two fields refer to the type and size of the vessel. Both files are menus. Then, under the category Location Information, the following data are registered. The wider location is selected from a list. The sailing and motion status of the vessel are selected from several sets of radio buttons. A checkbox indicates if the vessel is moored alongside another vessel. As we can see, drop-down menu is an equivalent question type to the radio buttons. However, when the options are not too many, radio buttons are more advantageous in terms of clarity, since all options are visible and clearly explained. One may also notice that there is no Other option in any of the fields. This assists further in clarity, user-friendliness, and quality of statistics. It requires meticulous design, though. Weather conditions are registered in steps. Whenever a value is required, it is important to use only meaningful accuracy. Fake or too big accuracy will add unnecessary complexity. The form designer's selection between a checkbox, a set of radio buttons, a menu, or any other input method depends on the characteristics of each field. Still no text boxes. The use of the input methods, as mentioned earlier, enhances the simplicity of the form, reduces the required completion time, and eases the statistical analysis. Finally, there are some text boxes in the VIRP form. Unfortunately, description and a couple of other pieces of information cannot be formulated in one of the other input methods. The input in the text boxes cannot be used directly for statistical analysis and is subject to the administrator's validation process. The user is not required to give extensive descriptions that reveal the identity of the parties involved. On the contrary, the purpose of this field is to stay concise and record only safety-related information that is not discussing identification or other sensitive information. Statistical analysis. This section aims to study the data recorded during the pilot stage and test the statistical tools of VIRP. The statistical results are unsuitable for decision-making since the platform was in the pilot stage. However, the sample is adequate to discuss several common issues that the user should consider before consulting the results of any statistical analysis. Before we start, we will briefly introduce the data stored during the pilot stage in VIRP database. Any credible statistical analysis should include a similar section. The first part of the pilot phase took place between the years 2018 to 2020, and 789 reports have been registered. During the second part, years 2021-2022, the way of recording incident has been upgraded, and 207 more reports have been registered. At the end of this part, 37 companies have been listed with 77 active users, representing approximately 1,200 vessels of different types and sizes. The sample was considered sufficient for testing the available statistical analysis tools and represents a successful proof of concept. Almost every type of merchant vessel can report incidents in VIRP. A closer look at the data collected until now shows that the database contains reports mainly of 4 major types of vessels: bulk carriers, container ships, gas carriers, and tankers. Over 73% of the entire database refers to tanker incidents, while approximately 16% is associated with bulk carriers. Container ships represent 8.7%, and the remaining 2.6% is referred to gas carriers. Near-miss reporting is very important. VIRP platform encourages companies to report near misses, which are treated the same way incidents are. Almost 88% of the reports refer to near misses, while the remaining 12% refer to accidents. Not all incidents are equally important. VIRP has integrated the high potential incident in its concept to highlight the incidents that count more. The companies tag 6.3% of the reported incidents as high potential incidents. Incidents have been categorized into several categories: collision, grounding, oil spill, fire, personnel injury or fatality, several types of failures, and cargo issues are the main categories supported in VIRP platform. Categories do not appear with the same frequency in the reports as shown in the graph. This, however, should not be confused with the frequency that occurs in real life. Companies do not report all their incidents, while each company has its own perception of which incidents are worth reporting in VIRP platform. The presented distribution should be considered more as an indication of the interest of the subscribed companies in these types of incidents. That being said, the most popular categories are mechanical failure, which entails almost half of the reports, personnel injury, and electrical failure. The incident's root cause is one of the most important outcomes of the incident report. This information is the source of the lessons learned and the target of the preventing actions. The root cause is a mandatory field in the incident reporting of VIRP. Thus, the incident investigation is a prerequisite. There are several predefined root cause tags as mentioned in the graph above. Outcomes, contrary to the prevailing industry perception, should be embraced with caution. Statistical analysis can be highly misleading if the sample context is not carefully investigated. This graph is a representative example. By studying the presented graph, one may easily conclude that 4 major root causes are rarely associated with incidents. These root causes are poor communication, fatigue, inadequate teamwork spirit and cooperation, and poor management of change. All of them are associated with the human factor issue, while refreshing and soft skills training is a standard prevention action for these issues. A deeper analysis of the selection of the incidents that the companies report and verification of the root cause identification during the incident investigation process is highly advised to be carried out before considering such a conclusion as genuine. Seeking trends. This graph shows a distribution of incidents in terms of the wind force. It appears that most incidents happen between 2 and 3 Beaufort scales. Let's see the distribution of incidents in terms of sea state. The distribution is similar, with a peak at sea states 1 to 3. It seems that reported incidents occur mainly in moderate conditions or once the weather starts to deteriorate. On the other hand, this conclusion does not seem to apply to high potential incidents. Yet, high potential incidents do not have a specific weather region. Another interesting graph shows the distribution of incidents based on the vessel's operations. More than half of the incidents are related to store handling, 56%. This is an interesting, albeit unexpected result. Yet it is suggested to be investigated further, since it looks that during the pilot phase, most companies registered incidents mainly for this operation. The following graphs indicate that the sample could not be considered representative of the entire world fleet. On the left pie chart, we have more than 400 reports of incidents during store handling, mainly for tanker vessels. While on the right-hand pie chart, only 20 reports are during the last 24 months. Most probably, the register process of incident reports has been changed over this period. This kind of issue may occur in any valid data set, and it is the user's responsibility to cross-check the quality of the sample before using the statistical results further. Before closing, it is worth discussing the sample in more depth and how representative that is. As a reference, we used published data from Equasis, which has access to almost the entire world fleet. It is now apparent that VIRP vessel type distribution is not similar to the estimated world vessel type distribution. Once again, the user has to be careful about their conclusion. These graphs do not reveal any problem with the data in VIRP. It is expected that samples from the real world may not be representative of all situations. The aim of studying the characteristics of a sample is to adapt the statistical analysis to the sample. In the presented example, the conclusion is that any qualities that depend on vessel type should be analyzed within each vessel type subsample. The value of VIRP. In the previous sessions, the fundamental principles of an incident reporting system, the VIRP incident report, and the automatic statistical tools of the platform have been presented and analyzed. In the next couple of slides, the value of the voluntary incident reporting platform of Helmepa will be presented. VIRP follows all the required fundamental principles to successfully implement an incident reporting system, and the most important added value is that it provides intercompany information. There are only a few intercompany platforms for incident reporting worldwide. VIRP operates voluntarily and offers high-level anonymity characteristics. The identification traces on the authors or company of the reports are, by design, completely erased, and there is no way to trace them back. Anonymity and voluntary use, combined with the strong supervision of Helmepa, a recognized independent, non-commercially driven body, ensures high credibility and recognition. Further advantages of VIRP are the inherent validation process, which ensures high-quality data, the simple and user-friendly interface that offers a great user experience, and the transparent procedures that provide further credibility. The benefits for an organization subscribed to VIRP are benchmarking, knowledge, and participation. Intercompany data of VIRP are a direct and credible source for benchmarking within each company's self-assessment. Such information is rare and hard to acquire, while precious for establishing a good safety culture. At the same time, the company is getting access to new cases, broadening its safety knowledge base beyond the experience of its own trade. Last but not least, benchmarking and broader knowledge, combined with the fact that the company participates in recognized safety campaigns, build a profile of a leading company and contribute to the company's reputation. On the other side of VIRP, the side of the management by Helmepa, VIRP has focused on features that make its management effective and efficient. The design philosophy of the incident report, with the extensive use of carefully preselected options and the inherent anonymity features, keeps the management and validation process simple and efficient. At the same time, the powerful data filters and the available statistical tools assist in easy and practical analysis. A vital characteristic of the system is that Helmepper can keep complete control of the data of VIRP, while each subscribed company keeps total anonymity in the registered reports. From the reports already registered, Helmepper has produced articles for a new magazine, VIRP Digest. This publication of Helmepper includes the presentation of interesting anonymous incidents, further analysis of selected cases, safety trends, and other useful safety-related information. This brief course is now complete. In these almost 40 minutes, the fundamentals of incident reporting systems have been discussed, and the use of VIRP, a modern intercompany application for incident reporting in the maritime industry, has been presented. Dynamarine, Helmepper, Cymepper, and Lloyd's Register and Foundation hope this course was inspired towards our ultimate goal of safety and protection of the environment and our seas. Thank you for your participation.